The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. A lot of people know us from the 2018 eruption of Kilauea in the Lower East Rift Zone. Working under Hawaii Tracker on the Facebook group. Since then, we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption and try and prepare for the next major disaster that comes to our island.
Yeah, and so we do that through two different programs. One is volcano education, and the other part is digital resilience, which we address through online groups on social media. So the way the two programs work together is that the social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well.
What we were working for really came about in the Mauna Loa eruption in 2022. Within hours of that eruption starting, we had the mayor, Mitch Roth, we had USGS-HVO Ken Hahn on the stream trying to help flush out a little bit of the ongoing because it's so new. It's completely different from our previous major eruption, which was 2018.
One of the things that Talmadge and I were talking about was how do we deal with social media? It was something we needed to figure out and get right. Our job is to get information to the public and make sure that the public get it as well as possible and as correctly as possible. When Philip and Dane started coming to and live streaming the meetings, it was great because we were reaching more people than we normally would. So when the eruption actually happened, we had this relationship. The interviews we did during the eruption, the most fun ones were the ones with Philip and Dave because they were more relaxed and we knew we were getting to the local community and people were asking questions. So those were the best, I think. I just want to really give a shout out to those guys and how we worked as a team on this eruption. It really worked out well and we got to a lot of people we wouldn't have normally gotten.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont from a nonprofit HVERI, the Hawaiian Volcano Education and Resilience Institute. Today is Thursday, September 12th, 2024. Kilauea is still quaking away, slowly but surely, but no big changes on the volcano this past week, Dane. How are you doing today?
Doing pretty good. Yeah, just keeping an eye on it and going through the historic trends that we'll be talking about more later on today.
Yeah, so speaking of that, we'll go through a regular update as usual in the first half. We'll finish up our 1960s series on the back half. I do want to acknowledge that we are 1 year on from our most recent summit eruption of Kīlauea. That was September 10th to 16th last year. But we will postpone covering that until next week, just so we can finish up our 1960s series this week here, to your point, Dane. So yeah, what else would you like to add?
No, sounds like a plan. If anybody has any questions, we're going to be doing two parts. First part's on current activity, and then the second part, the second half, is going to be on the end of the 1960s. So if you have questions, we'll be in two segments. Drop them in the chat, and we'll see what we can do.
Yeah, thanks, Dane, for leading that and collecting those. And thanks to Lou on the back end. And as always, thanks to our ASL interpreters, Dano and Carrie, not Danny. All right, so let's get our titles lined up here and start off with our Hawaiian volcano summary this week. All right. Aloha, everyone. This is our Hawaiian volcano summary for September 12th, 2024. Kilauea continues to show earthquakes on its Upper East Rift connector and the Middle East Rift zone by Makaopuhi crater. This is continuing the pattern of adjustment following the intrusions we've had in this area over the past month and a half or so. But no major changes, nothing really significant has changed. We're just seeing the continued movement of magma within the summit area, which seems to be slowing in this Upper East Rift and Middle East Rift area, and perhaps speeding up a little bit in the summit area, very slightly, within the same kind of pulsing pattern that we've seen over the last few months. Downrift of the Makaopuhi area by Puʻu'ōʻō, there is still no sign of ground movement relating to magma injecting underneath there. So the threat still remains within a national park for any activity to happen. And while things are adjusting underground now, that's usually what happens, there is still a chance that some new pulse of activity might lead to a crack that makes its way all the way to the surface and releases an eruption. So that's still a possibility, but doesn't seem very imminent at this point in time. If we look at the earthquake rates, we can see here that we've climbed up today in our counts after a lull earlier in the week, but this is following that cycle of pulses and the counts of earthquakes that we're getting here. That follows the last big adjustment we had in mid-August. Looking at the tilt meters, as our GPS data is still not updating to the website, we can see that at the summit at Uekahuna, over the last week, we have, over the last month, we can see this net gain in tilt here. And while last week, this pattern was more or less flat, you can see that over this most recent week, it has actually been rising. Not huge amounts, but it is resuming inflation at the summit there. If we go closer to the recent intrusion site by the escape road, we can see continued movement of the different components of ground tilt here. But they're not moving nearly as fast as during the intrusion or subsequent adjustment periods that we've had. Even through here, we can see the rate was a little steeper and has been flattening out more recently over the last week here. So that seems to be stabilizing in the intrusion area. Moving further down to the Puʻu'ōʻō area, here is where we can see in the blue line the signal that points to the rift zone under Puʻu'ōʻō, and it continues to deflate. The signal we do detect there is coming from the west, and this green line component that is detecting the inflation from the Makaopuhi reservoir to the west. So that's the story in Kilauea, similar to recent weeks. A little slower here, but with the same prognosis looking forward. Turning to Mauna Loa, it's been fairly quiet there as well. Here are earthquakes per month, still very low on Mauna Loa as we recover from the 2022 eruption that had much higher counts of earthquakes. Looking at the tilt on Mauna Loa summit, you can see here it is a very slow inflation pattern happening. And we happen to see this very well because of this earthquake jolt that reset the scale in the tilt meter here. So this is really showing us the long-term pattern a little more clearly because of that automatic scaling. As far as where those earthquakes are occurring, there's very few. They're in the summit area, and there are a couple notable ones that have been have registered that are deeper than typical earthquakes under the summit here. And to recap this particular storyline, we have seen this recently within the last year. And this is a plot of depth versus time here. And so these colored purples, blues, and greens you see actually began to flare up a little less than a year ago here and have come in several pulses of activity as we imagine that magma from deep is replenishing the reservoir, and then the island underneath the mountain is also adjusting to the redistribution of weight. So that may be returning with these two most recent events, but we will await the developments on Mauna Loa to see what happens. That still does not lead to any increased threat of activity on the volcano. It's just an interesting follow-up to this recharge pattern following 2022. And that's our summary for this week. And I'll move on to our observations on Kilauea, for which we would just look at the last 24 hours here from the KW camera, the live USGS live camera, looking into the Halemaumau crater in Kaluapele, the main caldera. So you see there's still fume coming out from beneath this crusted lava lake. There's probably certainly some gooey lava down underneath that crust in there somewhere. So it's still degassing, and you see that leaking out through the crust above here. Otherwise, very little action apart from the weather coming through occasionally here. So not a whole lot to see on the summit of Kilauea apart from these slow changes. So we'll move on to the earthquakes maps. And to start, we'll look at the last 2 weeks here across the whole island. Once again, these are colored by depth. So the blue ones are deep, the red ones are shallow. And we see lots of adjustment earthquakes in the background, as we saw last week as well. We see adjustments here in the flank of Mauna Loa to what's happening on Kilauea. We see Kilauea in the red, and we see the Pahala deep earthquake cluster here that we've long seen for almost 10 years now, coming from that hotspot zone deep under the island and presumably feeding into the volcanoes. So let's refine it to the last 2 days and clear out some of that background. And even within the last 2 days, you see there's still quite a lot of earthquakes here on Kilauea. And if we zoom it in a little more and a little more, you'll see they actually are popping up in 3 clusters. We have a South Caldera cluster right here, with the shallowest event at 2.2 that occurred yesterday. We have a second cluster in the Upper East Rift connector here, Upper East Rift zone, right there, and it kind of centers near Ko'oko'olau crater, I believe, which is this one right in here. So kind of in there, kind of near the edge of Puhimau right here. There's that thermal area. The edge of the caldera is in here. So this is more or less the connecting zone, right? We saw the intrusions occur last month in the area of Pauahi crater, which is here, and Maunaulu here. So something like there and there were the 2 blades that injected. And after that, we saw the opening into the Middle East Rift Zone and the filling of magma into the Makaopuhi reservoir, which is somewhere in here. It probably takes something like a path like that, and somewhere in this jog at a bend is this reservoir area right through there, which is why you have the largest crater on the East Rift Zone, Makaopuhi crater right here, and a lava shield of Kananui Hamo that are one next to the other right over that magma reservoir. So that's the third spot, and those are the 3 areas that are flaring up with the continued filling of magma. So let's go to our other earthquake map, which is the one colored by time. You can see our most recent events in red now, and our older ones over the last week in yellow. with the last 2 days in orange as well. So you can see that the most recent events are still happening in Kilauea. It's still flaring up. So we can see here 1.7 that occurred within the last 15 minutes, 1.7, 2.0, 2.3, 2.3, 1.9, 2.1, 2.2. So some decent sized ones in here. Still flaring up. If we come back to just the last day, you can see there's still quite a lot right there. Maybe that's a clearer way to show it visually, how active it is and where we're the most active. It's still mostly in here. And so that corresponds to our signals coming from the summit area and perhaps the Upper East Rift, and less so from the Middle East Rift here, where maybe this is stabilizing but still pushing to cause these earthquakes. So yeah, that's the story here with the earthquakes. We'll move on to our monitoring signals on Kilauea. And I will start off by showing today's USGS daily update, which reminds us the volcano is not erupting. Activity has been low in the Upper East Rift Zone over the last 24 hours, but additional pulses of unrest in the Upper to Middle East Rift Zone are possible and may evolve quickly. That's the key quote there. As usual, they're recounting the numbers of earthquakes. So they're saying 75 is higher than the previous day. In our Upper East Rift, they're showing 123, 30 on the south flank. So it's nice to see them updating these numbers every single day. I won't, they're just know that they're up slightly over the last day. Here's where they state that. This is a definite increase over recent days, but still far below the levels of activity seen during recent episodes of unrest. And otherwise, things are fairly stable. They note how things are not happening by Puʻu'ōʻō, and that pulses of magma are still coming into the volcano to cause this unrest. So not a lot of change in the update here, but that's just to touch base with our source. There is the text update. We do not have good GPS data coming into the website yet, so we will rely on tilt once again. If we look just the last 2 days at the summit, it looks like it's a rising trend here. That's all you see. Just zoomed way in, you see maybe 2 microradians of increase, but really it's only telling you a little bit. That's just a little section right through here, where really it's part of a bigger trend that goes back a couple of days now, where this seems to have begun, right? And depending whether you include this little pulse in the middle of last week as well, you can count the entire thing as an upward trend over the last week here, which, as we stated earlier, is a different trend than the previous week, where it was a little bit flatter. So looking at the other tilt meters, this one's Kilauea Iki, slightly further east. It's mirroring that pattern of slight inflation from the summit area at Halemaumau. And it's actually showing, in this case, some deflation towards its most proximal part of the East Rift connector. Sand Hill is a station south and slightly west of the summit caldera there. And over the last week, there is one interesting little wiggle signal right in there. And that only appears in this one tilt meter in this one location. So similar to the one we saw the previous week, this one over here, which changed things in the opposite direction. This is likely to be a localized adjustment of that area. So maybe there's a loose slab of a sliver of ground there that, as the volcano swells more to the north or more to the south, that just wiggles a little more this way or that way, and ever so slightly or something along those lines could cause this back and forth, very localized signal, something like that. But otherwise, it's showing inflation at the summit as well from Halemaumau. And what this shows us, in addition, is inflation from the South Caldera area as well there. So South Caldera inflation and Halemaumau inflation, both shown on this plot. We'll move further down the rift and just remind you of the stabilization. We pointed this out last week, but I'll restate it. The scale on this plot is extremely massive, really zoomed out. 50 microradians per box. So we see this dropping down very slightly here, but it's actually likely moving faster than it usually does. And it's hard to tell at this level of zoom, right? But what we're looking at is the difference in the slope of that line to the slope of the line over here. So last week we could clearly see it was going down. Now maybe a little bit more stabilized, but still dropping and likely still filling slightly there. And at Puʻu'ōʻō, we don't see that signal there. West from Makaopuhi and nothing from the rift zone. Jonica, further down the rift zone, is only showing big earthquake shocks and otherwise deflating with no significant signal as well. So that's the tilt. That shows us what's happening with each block of the volcano. We can go through and compare the tilt data to our earthquake and try to synthesize the data. So we can see here, for example, that in the last 2 days, when our tilt is increasing at the summit, is also when we have the earthquake counts increasing as well, right? Also in that summit area. So likely that pathway from that summit to that Upper East Rift connector into the Middle East Rift is not a persistently open pathway, it seems. Like there seems to be something catching it. Occasionally, depending, the inflation center is not able to reach its pressure across and fill that rift zone area. And instead, it seems to be filling the caldera area and causing earthquakes and inflation there, at least this week. And as we've seen in the past, that seems to move around week to week from north to south and southeast, perhaps even further. So that's been a really interesting area of adjustment here on Kilauea. And there's our most recent post coming up in a shallow depth range in the last couple of days. And there's the one that we had earlier last week as well. There's a gap in between. Deep earthquakes still ongoing, nothing unusual happening there on Kilauea. We've seen the map. There it is. I haven't pointed out the south flank earthquakes are still ongoing. One thing that's quite common in historical eruptions is when you have injections of magma in areas like this, the area right next to it in the south flank will adjust more and more and more. When you have injections over here, you have adjustment of the south flank here, much, much more. And you would expect that if it's trying to push further east, then you have more earthquakes over here. So this south flank area right there is going to be something to watch to see if there are any big events or increases in numbers of events as an extra indicator of what the rift zone is doing, whether it's opening or not by the movement of the flank. Okay, so I'll scroll past the cross section. Here's our last month where we see that overall trend. The last month at Sand Hill we saw already. And then the earthquakes, you see a little bit more of the pattern of pulsing from the deep Pahala zone, but nothing significant there since it's so far away. This is really 30 miles down from the volcano. All right, earthquake counts for the month. We saw and talked about the pulsing during our summary. And there it is again. And here over the last year, earthquakes per week now, we can see that we're still at elevated levels compared to times between eruptions, most recently here. All right. So still high earthquake counts per month. And we'll move on to just show you the GPS has a big data gap over here on the right, which is why we're not covering GPS presently. Yep. Okay, that's our monitoring signals. Apart from, we do have one more image come through from the Mountains project. This is an automated software that's collecting the satellite passes and trying to calculate automated elevation change measurements on these maps. Right, so our most recent image is this one right here. It was released on the 12th today and goes back 12 days to essentially the 31st of August right there. So what can you actually see here? It's a little tricky to pick this out. I'm trying to study this a little bit. And so there's the key thing to when you're looking at these and trying to figure this out is to look at this key on the right side here, right? And for example, if you see if you see like let's see like a center of something happening, and it's right there. We have blue and we have green. So towards the center, we're going green to blue. So if we look at green to blue is that way, and that is away from the radar. So right over here, we have an area of deflation just west of the rim of the caldera. And following that same kind of pattern, you actually can see that there is inflation within the lava lake pit itself, Hale Mau. And otherwise, over here, we go from yellow to red. That's in this direction there. That's toward the radar. So the inflation center on this image seems to be down over here. And just off the path of the East Rift connector, slightly to the west, those intrusions happen just off the map over this way. And you do see a little bit of a hint of this, almost like a pathway coming through here, right? It looks a little bit like a pathway. It's inflating in this stripe north to south that seems to parallel the East Rift connector right through there. So we can't really see the Middle East Rift zone further from here. We can't really see the intrusion sites off the map right over here. Sometimes we'd see those rainbows back on here. We can show you some of the previous images to compare that. But this is what we see today. Let's look maybe here inflating, maybe here inflating, and here deflating. Right? When we imagine a net movement that way, but possibly catching somewhere in here within the last 2 days or so, because the earthquakes are popping up here. And this image is summing up the whole last 2 weeks altogether. So looking at the image previous to that, the previous 2 weeks to that, here it is. We actually were seeing deflation up at the summit. Prior to that, we were seeing inflation more so at the South Caldera, like you see right in here. This spread as far south as the Kauai, but you can see it's much more in this central South Caldera. Not so much the stripe we saw on the east this last 2 weeks, so it's interesting. And let's go back one more frame there. You can see once again here, the center is more right in the center of the caldera. And one more, it goes back to our intrusionary pulse. So here is where we can see some little rainbow stripes kind of at the edge. They kind of go like that, right through there of our intrusion zone. And you can see that there was also a big deformation center on the Kauai as well, and in the pit, big deflation from the summit as we had intrusion into the rift. So let's move it back forward for you guys. As you can see how it evolved since mid-July is where this is. So mid-July, the beginning of August, in the middle of August there, and the end of August, and now you see. So that's what we mean by the centers of inflation moving around, and it just reflects how there's a really complex reservoir, right? It's not just one big balloon that fills with magma and it just all leaks out through one pipe. It's a whole network of cracks and ledges and all this weird shape stuff that all connects. And so if it fills up in one area, it can move pressure to somewhere else and balloon somewhere else, and it can be all connected in weird ways. And the pathways can be transient, where sometimes they're easy to move through and sometimes they're not. So the pressure can transfer, sometimes it can't. And that's what makes it so hard to predict, really. So things are still changing with where the magma is building up. And that's the most recent image we have. All right, so with that, we'll jump to our volcano watch for the week. And we'll stick it in here because this is actually in the context of what's happening now. The recent intrusions follow the pattern of previous events. So this is posted online. Here it's recounting our intrusion that occurred earlier in August and the earthquakes that came along with it there. They also are recounting that there were similar intrusions in 2007 and 2011 during the Puʻu'ōʻō eruption era. And that's what they're choosing to pull out to compare against this week here. They note that 2007 Father's Day intrusion was very similar location to the current intrusions. It actually was kind of leaked out a little bit right there in Kananoihamo, but most of the lava was accommodated in a crack in an intrusion that went further underground than that. So they note that one. And they also note that in 2011, there was Kamoamoa eruption, right? That's the one, that's the area that's between It's just west of Puʻu'ōʻō, I'll say. And when that happened, that eruption, I want to say it lasted maybe 4 days, something like that. It did disrupt the Puʻu'ōʻō eruption, and dropped a lava lake at the summit. But following those few days, the lava resumed its path to Puʻu'ōʻō and continued as before. So their point here is that even while lava was moving through the system to Puʻu'ōʻō, you were able to have interruptions that did not stop the flow of lava for very long. And essentially, there was multiple elevations within the ground there that multiple depths where the magma can be moving, and multiple pathways as well. So just because you have a disruption and an intrusion doesn't mean you can't have a second pathway also active at the same time that resumes quite quickly as well. So more interesting information for us to assimilate. They also note in this article, I think it's maybe the first time I've seen this noted in the Volcano Watch, and we've been adopting this convention for a little while, but they note that they are now using new vocabulary on this part of the rift. We still refer to the East Rift Zone as upper, middle, and lower sections, with the upper section being the one that bends. And here they note that upper East Rift Zone is unique in that there has not been measured spreading across the rift. Instead, the opening occurs on faults that are on an angle of the Middle East Rift, I'll say, east and west trending, right? So because of this, Don Swanson suggests referring to that upper section as the East Rift Connector, because it connects the proper east trending part of the East Rift Zone to the caldera. So these days you could see either term used, they refer to the same structure. So yeah, the difference between the Puʻu'ō era in 2007, 2011, and now is that we don't have magma going through Puʻu'ō. It's not erupting out of there. The point being that even though we have all this intrusions and dikes coming in the Middle East Rift Zone now, it does not guarantee that will form a pathway further past Puʻu'ō down a rift. It has to take particular pathways to get there. So that's what they're getting at here. So even though there is not a pathway established there, we know that when things happen in this part of the rift, it does not always affect the section a few miles downhill. And that's the takeaway, I think, from here. And so that's the Volcano Watch this week. Let me step through some of the other segments we have here before our break, and then I'm going to have to go and fix my power here, guys, just so you guys know, I have a heads up. But all right, so for our gas, we'll turn to the VOG Measurement and Prediction Project from University of Hawaii Manoa. Their forecast now is probably putting out too much gas from volcano based on the measurements we've seen reported. But you do see the dispersion pattern of where the gas would actually blow. So during trade winds, which have not been as persistent as sometimes, that would go southwest towards Pahala area, not Oahu Ocean View. But during these Kona winds or slack winds, you might see the VOG blowing into the saddle to the north, or sometimes further up towards Hamakua as well. So it's still possible, but not a whole lot's coming out, so it's not likely anyone will be smelling it or be impacted by it too much. The closest place to the emissions is in a national park, and within that area, everything is in the green and has been within the green for the last 24 hours. So that is our hazard summary. We'll quickly touch base on Mauna Loa. We do have some photographs from the USGS who have been maintaining the equipment over on Hualalai and Mauna Loa both. So here you can see in the Hualalai station maintenance, they installed a voice repeater to assist radio communications between locations there. Upgraded the batteries recently to lithium batteries. And there you see the work on the Hualalai repeater site. They're up on Kohala as well. Upgrading the seismic sensor and digitizers. Fixing things up there, replacing power cables. And then you also go, and I don't have any pictures from station TOUO high on the west flank of Mauna Loa. So they are out and about, making sure the equipment is functioning, and they have a lot of work to do with so much equipment. That's kind of the flip side of that. So on the signals, zooming into the last week, we see just the daily variations, so nothing really significant there. What's more important is this average rising, which we pointed out on that month-long tilt that we'll see here. As far as our deep earthquakes, here they are popping up the last two over the last week. See one on the 6th, one just before the 8th. And there's our long-term tilt. And there's our two recent earthquakes, depth versus the last month of time here. So they're just popping in here to start after one kind of really small deep one off last week we mentioned in passing. The rates are still quite low, so it's nothing really significant. It's just where they're occurring more so than how many. Right, so the rates are still low, as we pointed out before. It's more so if we look at this whole last year, let's call it, right? Or here, let's look at the last week first and look in cross-section. Directly below, there's where the earthquakes are occurring. One on the flank, one beneath the caldera, there and there. And we'll scroll over to, this is the last month, and this is the whole last year. So you see how they fit into that pattern. It was just the one there, and one there. And not too similar to the actual deep flurry we had earlier in the year there. And just put everything in context. So, and as we started off, there is that depth and time showing these coming in. And you can see that these are actually quite a bit shallower than these events that we had previously. And so we'll wait and see what happens next there. And with that, guys, I will pass it to Lou to do our community corner and say our thank yous, and I will go fix my issue here.
Yeah, we'll hold down the fort until you get back. All right, thank you, Phil. All right, go ahead and get Lou in here. Hey, Lou, how you doing?
Doing good.
All right. So, yeah, we got a community corner on deck, yeah?
We do. Let's get that up on the screen there. Thank you very much. There we are. We do have some things, some updates on what's going on in the park. I want to say thank you very much to Yvonne Barr, who sent me some pictures this morning of some current shots that are going on up there. Everybody knows the construction's going on there, and there's going to be delays, so expect closures. Hawaiian Volcanoes National Park has begun a 2-year construction project. I can't emphasize that enough because we know with rain, with storms, with eruptions, that can change. So know that that's going to be pliable, right? To repair, improve, and remove damaged buildings, infrastructure at the summit of Kilauea. Park visitors and tour operators should expect delays at the entrance station, temporary area closures, and limited parking. Delays and lack of parking will be even more severe during periods of high visitation, such as during an eruption and the traditional busy months of December, January, June, July, and August.
So if you were up at the summit last year at this time for that eruption and you thought it was packed, just wait. If it goes off again, it's going to be a madhouse up there with no parking, just everything in construction. It'd still be worth seeing, but just be prepared, especially at peak hours.
Yeah, last year we had the parking lot up top,
right?
And this time we don't have that luxury. And even though the eruption was short, what was I think 6 days last year? Is that about right? It was busy, and we haven't had an eruption now for a year. It's going to be 10 times busier just for the fact that we haven't had an eruption. So buckle in, everybody. Be prepared.
Yeah.
There we go. Some shots of what's going on up there. We do know that I do have an update at the visitor center. The visitor center is still open, and the bathrooms, the regular bathrooms, are still open there. That's a plus. If you are up at Waikahuna, they have the famous porta potties up there, but there is still facilities if you need them. And at the park, even though they're after dark and the park programs are halted, they do have hula arts on Saturday, September 14th at 10:30. It's an hour. This is a good one. This is put on by the Volcano Arts Center, highlighting the timeless beauty of hula, Kahiko traditional hula. Proudly presented as a part of an ongoing series supported by the Volcano Arts Center. This event welcomes esteemed hula hakau, did I say that right? Halau, from across Hawaii to share their talents each month. Immerse yourself in the rhythmic movements and rich culture heritage as the hour-long performance unfolds amidst the serene backdrop of the Kahua Hula in the Hawaiʻi Volcanoes National Park. Now, this is outdoors, so they're encouraging you to bring rain gear and seating mats. And today it started off raining, and then it went sunny up, fills up the hill for me. You just heard him talking about solar, so that tells me that it's been raining up there. So just get there prepared. It's free to go to watch this, but entrance fees still apply going into the park. Due to limited parking at the visitor center, right, pay attention to that. We recommend arriving early and carpooling to ensure a seamless experience. Additional parking is available at the Steam Vents parking lot. It's worth parking up there anyway and walking down, because it's a nice walk through the steam vents to the sulfur fields. They've got a beautiful boardwalk that's all through there. So it's definitely worth it to take that extra time. It's not that far at all. And we have on Tuesday, September 24th, the long-awaited blessing ceremony at Highway 37 at the Four Corners, 10 o'clock in the morning. You can see this is an aerial shot that I took from a flight some time ago. I think it was last year, Dane. I took that flight. And it's only one corner now, but I guess you could say three if you count the road to the lighthouse. But that is going to start the road construction project that's headed back through Kapoho and around. Dane, you want to talk about that at all?
Yeah, so this project got started after 2018. We did have the Highway 132, which connects to Four Corners. That got redone a year after the eruption or so. And after a lot of work and talking about what's going to be restored, the decision's been made, and now we're already breaking ground. The dozers are out there already, pushing a road from Four Corners in Kapoho, 3 miles, over 3.5 miles to the Poʻiki Beach, and restoring the Red Road. And then they're going to restore Poʻiki Road, and then the section of road between Poʻiki and McKinsey that got covered, that was temporarily restored. So all the major highways in Lower Puna that were taken in 2018 are getting redone, and this is the kind of the community coming together to be able to celebrate that we're crossing that bridge. And we have other projects going on as well, but this is one that finally the dozers are on the ground.
Yep. And we covered those other projects in some past live streams. So if you're curious about the dates, and we can drop a link once I get done talking here. I'll track down one of those videos and catch you up to speed if you don't know what the dates are and how the progression is going to go. And hopefully we can maybe catch this ceremony or some other ones that are going on, or keep you guys updated on the construction, because it's going to be a lot of activity over the next 2 years, right?
Yeah.
All right.
I think there's going to take less time than that for that one.
Yeah. They're going to move. Yeah. All right.
The question on that one is just how long does it take for the ground to be cool enough for them to be able to put in things like water lines, because this isn't just a road. There's water lines under the road, and the little things that the grommets inside the lines to keep the water from leaking out. I don't think they like high temperatures. So,
probably not.
Yeah, it's going to be a little bit of a process.
Yep. All right, next week on September 17th to the 19th, the Native Hawaiian Cultural Convention is going on over in Waikoloa. We will be attending that. It should be a fun event. And if you have not subscribed to our newsletter, this is a shot from last night. We were at a elementary school science fair showing some of our science experiments for teaching the kids on viscosity. And you can learn about all of this through our newsletter. So jump over there and hveri.org/subscribe. At the beginning of the month, we put out a newsletter of all the events that we're attending and happenings here at HVERI. There we go. And that is our community corner.
All right. Well, thank you, Lou. And it looks like Phil is back.
Yep.
So we can go ahead and move on. But before we do that, I'd like to go ahead and take this opportunity to thank everybody for being here. You know, the likes, the subscriptions, the shares, all that stuff really does help with the channel, getting it more seen in the algorithms. So we'd like to acknowledge everybody that is here today, especially when there's not an eruption. We get to discuss more and look at the historical parallels instead of just pretty lava fountains, or potentially worse. But yeah, we just want to thank everybody. We also like to thank the Hawaii Community Foundation, as well as the County of Hawaii through the Puna Strong and Kilauea Recovery Grants Program. So thanks and mahalo to everybody that keeps us going, and not just the live stream, but our digital resilience hubs, as well as our new youth development programs. So appreciate everybody. Thank you.
Yep, you can drop a super chat here on YouTube if you'd like to support us, or you can go to our website at hveri.org/donate. We are a 501c3 nonprofit organization. Mahalo for your support.
Yep. All right. Thank you, Lou. And I
You're
will
welcome.
go ahead and get Phil back on here. There we go. Welcome back, Phil. So I don't think I have much in the way of questions for you, really. There was a question about the Ring of Fire being connected potentially to Big Island. But, oh, you're muted, Phil.
Yeah, you've heard that answer before. You can probably repeat it already, right? So
yeah, no, it's not connected. And if the Ring of Fire does things, we're a hotspot that does things already, and so not connected. And there's eruptions going on all over the world. What, average 40 at any given time. So, and now we get to see all of them, right? Or more than we've ever seen before. So if you're watching some high definition volcano in a remote region, thanks to the technology and the communications to be able to do that. All right. And I think with that, we can go ahead and go back in time and talk about, I just want to check. I think I'm going to do the poll again. We talked about it last week. We haven't done the over under for a little while. So going to put it in play again on October 22nd. You can think about what side you want to. Yeah. So a little over a month, right? A month and 10 days. Do you think it'll erupt before then or after then? And we'll put that in chat as a poll. So yeah, I think that does it for this segment.
all right, sounds good. So we'll move on to our volcano awareness presentation for the week, where we will be revisiting the February 1969 eruption of Kilauea. And maybe let me put up the most famous image of that eruption here for you guys. And that's a February of 1969 eruption in Alai crater in this particular image right here. So let's get to this. Let's get to explaining what's going on here. But to start off, we'll recap our table of eruptions here and just recount that we're looking at the 9 eruptions that occurred in the 1960s. And they are bookended on either side. Before it is a 1960 eruption in Kapoho. That's very famous. After it is a 1969 to 74 eruption of Maunaulu, which is also famous. So we're looking at the era in between those two famous eruptions in the decade of the 1960s. And in that decade, there were 9 eruptions that occurred on that Middle East rift zone. And also there was a 9-month period of time of lava lake at the summit at Halemaumau in between there. So thus far on our previous broadcasts, we've covered this first 3 summit eruptions of 1961. And then we covered September 1961 on the flank, December 62. That was also on the flank. August 63 was only inside Alai crater, essentially. October 63 followed around Napau. March 65 in Makaopuhi, all the way down to Kīlauea. December 65 around Aloi crater. That was a Christmas Eve eruption we talked about last week. And that's where we ended last week. And after that's when we had this 9-month period of summit activity. So the next Middle East rift eruption doesn't occur until 1968. Right? So this was actually where we began our series, because this was in August. We talked about the anniversary of that eruption. So we've actually talked about August 68 and October 68 as well, because these two came as a package in our publication there. So here we are finally to February 69. This was February 22nd. The paper notes February 22nd as George Washington's birthday. That was what they were noting at the time there. It was a 6-day eruption, and it was essentially between Alai and Nepal craters. There. Yeah, so it put out a little more lava than some of the other eruptions, 0.02, right? That's what remains. But we'll get into that detail a little more clearly here. But to recap how it was actually looked in map format, right? Here's 1961, and where you see 22, that was September 22nd, or 22nd, 23rd, 24th, right? So that eruption came down not that far from Pahoa. It was the lowest fissure there. This is the first eruption following that East Rift activity. Then we had, after that, a reset in 1962 with eruptions happening between Eloi and Alai crater, and between Alai and Kananoyohamo, right there and there. And then in 63, it was only with an Alai crater. We're so zoomed in right there. October 63, we had it extended a little bit further back east. So after those first 3 eruptions that were all clustered and small, now we start having bigger ones occurring in the Middle East Rift, beginning with October 63. Followed with March 63, another bigger Middle East Rift eruption there. None of these is lasting super long and putting flows very far from the rift zone, but they are repaving an area that was very, very forested prior to this activity. So that was March 65. December 65 are these ones right here. There. In that similar area once again, maybe a little bit smaller once again. And then August and October of 68 are here, August and October of 68. Although August had here, but also all the way down off this map is what this is, right? Here's October there, and then further on, August reached further down as well. And finally, here's where we are today in February of 69. This is a map we have presented. So the fissures are labeled as letters A, B, C, D, E, and F is all the way over here. Those are the fissures of the 6-day eruption, which began over here just east of Alai crater. And there's Alai crater right there. Aloi is right here. The road, chain of craters would just go between them. Go to Makaopuhi. And we mentioned in previous episodes that at the time, the road actually would end at Makaopuhi. Well, in 1965, they then extended the road further down towards Kalapana. And we'll come back to that here in a little bit. But now you see the road actually going further past Makaopuhi and off a map to the south towards Kalapana as well. So let's look at this image of October of 68. This is the eruption that happened before. And it had been about 4 months until after that we have this eruption in February. So most of our information is going to come from Professional Paper 891. But we're also going to tap into this other paper by Don Swanson, which talks about Alai crater on its own, which went through massive changes beginning at this time. So this is the image of Alai crater prior to any of these eruptions. August of 65, showing at the bottom here, there was a little pad of lava lake from 1840 with some fissures on the wall as well. No, I'm sorry, not fissures on the wall. Yeah, so a little lava lake at the bottom there. And this was like a double crater. So there's an inner crater and there's a little mezzanine, as they call it, this little ledge, this little flatter ledge within the crater, but well below the upper rim. So this is what it looked like before, all forested, all up and down the rim. They note there's a little prehistoric cinder cone visible back here in the background. Okay, so after the 69 eruption, February 69 eruption, here is what that same view looked like. A massive, massive change. April 69, showing the February 69 lava lake, it filled the entire bottom right there. You can't even see the mezzanine, that little ledge, because it's all the way buried underneath here on the side by this lava. You can see, if I point out, there's a line of fissures that goes up the top here, and it goes down this far wall, and it crosses across the bottom of the crater over here. Keeps going off in that direction as well. And you see all the vegetation down. I'll pull it back to the before. And there's the after. And this was really the beginning of many years of change. This eruption of February 69 will lead into the Maunaulu eruption, as we discussed. And that eruption is what's going to obliterate Alai and completely reshape it to where it's no longer a crater anymore. So here's a view mid-November in the midst of that process where it looks nothing at all like either of the last two photographs, but it's actually still the same place. Actually, the photograph is taken from about 25 meters higher because there's new ground above the old overlook. So it is a slightly different perspective, but overall, it's massively reshaped there. So that's the context of Alai. And here we are to professional paper. I'll show you the cover here. 891, February 69, East Rift eruption of Kīlauea volcano. Right there. So this is by Don Swanson, Dallas Jackson, Bob Koyanagi, and Tom Wright. Some good scientists there. And they note here, and there's a summary abstract, that during that 6-day eruption, February 22nd to 28th, it did not quite get into March, stayed in February. 20 million cubic meters of lava, very roughly, covered an area of the Upper East Rift Zone. At the time, the largest recorded eruption on the Upper East Rift. Right? It was going to be superseded by the Maunaulu eruption that comes next. But in this case, up to that point, this was a big eruption, right? So the pattern is that the eruptions kind of began smaller, more like intrusions with some leakages. Then it kind of got bigger and bigger, led to this one, led to Maunaulu as the biggest one of the whole bunch. They note 11-kilometer long. So you're looking at maybe 6 miles or so, something like that, of fissures extending downrift. There was a 70-meter deep. You're looking at, it's that 230, 240 feet deep lava lake inside Alai, that whole inner pit inside of there. And it followed 4 months of inflation at both the summit and East Rift that immediately followed the October eruption. In fact, began before that eruption was barely even over. So that's the story, the big picture story. I'm going to scroll down past some of this stuff in here. There are some interesting things to note, right? They're looking at the tilt drops. When you're having these rift eruptions, you see the summit tilt drop a lot when eruptions occur. So let me scroll to the bottom here. October 68 eruption and February 69 eruption here. And that's what these black boxes correspond to. So they're pointing out when they had earthquakes, a series of South Flank earthquakes helping to open that East Rift to allow this stuff to happen, right? Both before and after the eruptions. And here is East Rift and South Flank number of earthquakes. So you see that there's a big pulse accompanying that this eruption in February. And there are previous ones, smaller pulses that occur in the South Flank. Some, you see little flare-ups. Eventually, a big one goes, and then the lava is able to leak out. As far as the summit's showing pulsing also. You can see here, not quite at the same time as the flank, pulsing of earthquakes at the summit as well. So a lot of parallels that we have going on here. This dilatation, as they call it, is actually what they're looking at as this triangle of land and the area of it, see if it's actually getting bigger or smaller. So if it's swelling, then the volcano is inflating, basically, right? Think of it that way. So you see that it actually is inflating around Halemaumau, right? So if it's inflating over here, then this thing will be shrinking. And that's what's telling you where the inflation is happening. So the center of inflation is at the summit up until just before, right? So here's a February eruption. Right in here is where we see that shrinking of the area of Halemaumau because the inflation has migrated likely to the south of here. Right? And so you see the migration of earthquakes and of pressure and of everything down to the rift, and eventually it erupts by the end of February there. So it was just like all the other events we've seen. There's that same pattern of earthquakes and ground deformation that you expect in advance. The way that they measured all this tilt, I'm going to skip by all these tilt plots. I'll just show you one summary view of that later. There were earthquakes occurring. Here's where the earthquakes were happening, right on the south flank there. And in particular, following that last eruption in October, we have a big cluster here south of Makaopuhi, allowing that rift zone to open. And here, okay, let's take this as a half of a panoramic. So let's show you the full panoramic here. So there's a panorama of a light crater after it was buried. And there's a wide view. I can zoom in so you can see some of these features a little better. Puʻu'ōʻō there in the background. February cones a little more clearly on the top of the rim, cutting down over the flank, spatter rampart across the now floor of the crater, right? This was actually the mezzanine before. So it was not the floor, but on the wall. But now it's on the floor, and it goes up the far wall and off that way, off this photograph, in fact. You see that they note the edge of the buried mezzanine. They note the lava lake crust was overturning. It overturned up to 2 days following the end of effusion of lava from the vents. Right, that's in mass across the entire lake. But actually, there was a final ooze up 5 days later from a spot over here near the center of the lake where it's marked. They very quickly after this was over, ran down there to try to start drilling into the lava lake to start measuring the thickness of the cooling rock and trying to get the samples from inside the lake. They were racing against time, and to let you know, this lasted until May when lava came in here and filled the whole crater and destroyed everything, including their little zip line they had to send stuff down into the crater and their water truck that was parked up at the top and stuff like that. But we'll get into that some other time. So there is drilling equipment right down in the middle. And here you also can see the initial vent A was actually off over here. And you can see the lava flow that came and cascaded into the crater from that direction, as well as the one that this fissure goes and keeps going off that way like that, kind of slanting back across the horizon. Well, keeps going to the right. There's our high lava mark over there. So there was some sagging and subsidence of the crust after everything was done in this particular phase. And so there you go. There's that full panorama of a light crater. And let me come back here to share with you guys the narrative and some highlights of the narrative of this eruption here. So they saw tremor and small earthquakes about 6:30 in the morning on February 22nd. By 9 in the morning, so you're talking about 2.5 hours later, they see continuous steady tremor, and they know an eruption is clearly imminent. So they're looking around. 50 minutes later, they spot fume. And because there are tourists still on Achenes Craters Road, they are very excited to report that they are the first ones to see the low lava fountains at event A, 300 to 500 meters northeast of Alai. And so that's about 9:50 in the morning or so. By 10:30, a line of vigorous fountains extends from just northeast of Alai crater to near the base of Kananui Ohamo. As the cracks propagate to the east, they successively step to the south, to the right. So, in other words, it's not one giant crack. You have a segment of cracks one, and then it seems to step over to the south, and another one, and steps to the south, and it keeps migrating that way. Right? They note the fountains reached 40 meters high, or instead of meters, yards, or by about 3, right? So it would be 130, 40 feet high near the east end of the line, building up a large spatter cone at Vent C. Fissures continue opening eastwards all the way to Kananui Ohamo. And fuming begins from new cracks northwest of there. So at this point, let me come back to our map and just point out, right? There is our vent A. We're migrating to the east and stepping to the south as we go. So there's another segment. There's vent C, and there's vent D. This is the lava shield of Kananui Ohamo like this, right? That's kind of high ground. And cut into it is the pit crater of Makaopuhi. And it also has an innermost crater right there that's deeper than that wider one. So that's a landscape here. And that's what we're talking about, is this propagation moving over in that direction there. So we have C and D both erupting, and lava goes south from them and crosses the Chain of Critters Road by 10:30. One part of vent C flow destroys a tourist overlook at Makaopuhi crater and spills over the rim and drops down 230 meters or yards, or what's that times? It's going to be about 700 feet down to the floor of that inner crater of Makaopuhi. It spreads out slowly in craggy lobes of A'a once it gets down there. Okay, so here's what I was talking about as far as the flow. The flow advanced with such force that it swept heavy equipment into the crater, including parts of a water trailer parked near the rim, and a heavy A-frame anchoring a tramway used in drilling operations within the crater. Eventually, 90% of the surface of the March 65 lava lake was covered by an A'a flow about 10 feet, 3 meters thick. Outside of Makaopuhi, that main flow continues going downslope following the road for another 2.5 kilometers, almost 1.5 miles or so. So it starts off as fluid pahoehoe at vent D, then changes, degasses, a bunch of it's pouring into the crater, and what keeps going down the road ends up being less fluid and changes into an A'a over a distance of 200 to 300 yards to the end of the flow there. So we have a picture of this flow. So here's a view. The vent D is actually, we're looking to the south. Here's the Chain of Critters Road that goes down towards Kalapana off that way. So vent D is down just off the map here, off the picture, and the flow is coming around. You can see a lot of dead trees down here, knocked over, and lava is pouring into the pit in all these different areas right there. And there is that inner pit of Makaopuhi. See the edge of the flow. Maybe if I zoom it in, you can see it better. There's the edge of the A'a flow right there going across that outer crater floor. Yeah. And then there is also this flow that hits the road and starts going right down the road. They're down the road all the way to right there, where you can see there the little finger really going only on the road. And so that's interesting. And there's a reverse angle picture of that one. This is not too unlike what we saw in 2018, Dane. Lava being attracted to the roads here. Look at this. There's a road right there. You can see the trace of it. And it goes off, comes back on, meanders back on. Like it keeps trying to find its way back to it. And it does, yeah. So pretty interesting. Yeah, right in there, it's really, really interesting right there. One segment goes straight down the road and joins a section that comes all the way around from both angles, right? But there was the road covered right in the middle. And there it is, uncovered.
It really did not want to try and go over that feature, but go around it and just stay on the road, come back to the road.
Yeah.
Yeah.
One thing's for sure, the road's got no giant cracks that everywhere else. This thing's been cracking for, this is the 9th eruption in 10 years up here, right? I mean, So yeah, there's a good reason for that, right?
Yeah.
And while we're talking about the road, here is just a little map of where the road goes today. This is from the national park, Chena Critters Road, right? And I do note it was dedicated originally in 1928 at a cost of $148,000 and ended at Makaopuhi. So the original route was actually this way, like that, over there. Then eventually it went down towards Kalapana, like probably something like that. Yeah, and it was opened in 1965 and then partly buried in 69 at the start of that eruption, actually just before in this February eruption of LA. Post that eruption, it was reopened in June 79 in its current configuration. So in case you're curious, that's a little bit of the high level history of the road there. So we'll come back to our paper here. Turn off your frog's name. There you go. All right. So the second of two flows in that area is fed by vent A. So let me come back to the map and just point out the map once again. There's vent C. There's that flow that goes down the road all the way to there. There's also a vent A, and it also puts out a flow that crosses the road also and comes and joins that flow as well right there. And look, it leaves a little island, what we call a kipuka. And it's the word for this area of calm in the middle of chaos, this untouched piece of land surrounded by lava right there. So let's come and look at that. And there is a story of that as well. So that second of the flows fed largely by vent A. Come down here. Change to downslope and eventually join a first flow a short distance south of Makaopuhi. And here is the highlight of this story. A national park ranger, returning from having conducted tourists out of the area, was trapped in his car between the two flows, spending a perilous 8 hours amid falling pumice, choking fume, and smoke from a burning forest before a daring helicopter rescue. Only natural levees built by the westernmost flow and an old spatter rampart south of Vent C that diverted the lava prevented the ranger and his car being inundated. After the rescue, his car remained as a landmark until flooded by lava in 1972, 3 years later. We've told this story before, but here it is actually in print in the USGS professional paper. Right, and come back to the map here. And that's where the ranger was stuck, right? So remember in 65, they've now extended the road. And so what this ranger's job was to go down the road. They knew the eruption had begun, go down the road and sweep the road, make sure no one's on the road, any tourists are here, go close the gate at the far end, and then come back. Well, he probably should have gone around a long way because when he came back, he came past here. This flow wasn't covering the road. He managed to drive all the way to here. This road was all the way open. He gets to here. He's like, oh, there's a flow. Can't cross it. Let's turn around and go back. It gets to here. Oh, crap. The flow's crossed the road here too. In that moment, since I got over here. So at what we've heard since then from other people telling the story is that there were no helicopters based on Hawaii Island in 1969. So they had to fly one over from Oahu, and that's why it took so long for the guy to get rescued. It must have been quite the experience to be stuck out there. And remember, everything is really forested, right? So you must be really scared of the fires as well. So there is that little kipuka, vents A and C. And with all this, we still haven't talked about Alai crater itself, really, and how it erupted. So we're going to get to that here shortly. Let me find our source here. What's really interesting, and I'll come back to the map, is that they actually saw A open first, and then second was C, and third was D, but they then named the Alai eruption fissure B, even though they saw it happen after D. So that's a little bit weird in this eruption here. And we'll see later that they actually note that they didn't know about this E and F eruptions until later when they knew about E, but they didn't know about at least F eruption fissures until later when they had Civil Air Patrol fly over and give them information. So yeah, there is another fissure here, E, that puts a flow around into Nepal crater and also across this fissure system right here. And I think that is also referred to. Let's just very briefly here. Let's see, somewhere, oh, we'll get to Nepal later, I suppose. But all right, the fissure has been slowly lengthening westward from A. So by 11:30, remember it was about 11 o'clock at Kananoyohamo. So it jumps back to the west and starts going west at 11:30. And by noon, a segment of the fissure is slowly splitting the mezzanine and western crater wall of Alai crater, and that's vent B. And that's when you have the spectacular 150, 180 feet high cascades pouring from the roaring fountains into the inner pit of the crater, feeding a rapidly deepening pool of molten lava. And so there are more studies of lava lakes, and we'll leave that to a different talk. The fissure reaches the west rim of Alai by 12:30, keeps going west. It actually keeps going all the way south of Aloi crater. And maybe once again, I'll pull up the map. And so now we're talking about fissure B, moving that way. It starts here, comes across, and it's going to get all the way to south of Aloi crater. There's Aloi crater. So, where was I? So yeah, it starts a fountain a few meters high. Those flows join the fountains that are feeding lava into Alai, and there's a big stream of lava going into that crater. By 12:45, hairline cracks had begun to form across the chain of craters road along a strike of the fissure. So maybe let me show this once again. So the actual overlook of Alai crater was somewhere right around in there. So when these fissures are happening over here, that's where they are looking. They're looking, they see the fissure come here, they see the fissure come across, they see the fissure going that way. And so that's when they retreat, because they see the cracks in the road right there. And they come to the other side of them because they don't want to be caught in the same position as the park ranger were. And so, given that, they note the cracks opening. And actually, rather than read this, I'll just show this series of photographs. But first let's look at this figure. This is the lava draping the wall of Makaopuhi, coming down the walls and feeding this a'a flow, which is still steaming here in the foreground. So someone walked down into the crater and took this photograph from the bottom there. And one thing that they note is all these talus cones, this debris here at the bottom against the pile, against the wall of the crater, is not dislodged wall rock, but rather it's predominantly falling a'a fragments that make up that stuff down there at the bottom. So interesting to note. Let's keep it going here. The fissure goes all the way south to Aloi crater. The fountains keep going for a little while there, but by late afternoon, fountaining is vigorous only at vent B and Alai and has stopped at vents A and C. Most of the area between Alai and Kananoyohamo is covered by flows, with a line of fountains centered over vent D also more than 100 meters high. So yeah, 300 feet high there, feeding a flow that goes all the way to the base and flowing east. So map once again, this flow right here, right? This big flow, that's the biggest flow we have. It actually goes north of the rift zone through this forest, covers some of the August 68 fissures at this far end over here. And that's what they're discussing right there. Here we go. The easternmost vent of E sent a tongue of slabby pahoehoe across the trail to Nepal crater, and small lobes of A'a into Nepal. So Nepal crater, there is Nepal crater. And there's that flow that comes from the backside and pours into it there. 4 little pads right on that northwest rim. And here. So they note that everything is kind of starting and stopping, and so maybe it's most useful to show you guys now this diagram. At the very west, there's B. At the very east is E and F, which are kind of unknown. But here is date and time from February 22nd for the 6 days of eruption when each event was active. So A, C began first, but they quickly shut off. D stayed persistent longer, just as long as B did. And then everything shuts off for almost a full day before you pick up back again at A, B, and D only, right in there. Right, and I see these little dash lines, it becomes a little bit intermittent as well. Yeah, so that's the pattern of which vents were actually active. I'll come back to the other image in a second there. No activity was observed for almost a day. And then at 3 p.m., vent A reopened and fountaining began. Fountains as high as 65 meters fed up a Hoihoe River that flowed westward and cascaded into Alai. That large pool of lava was ponded. There was also a large pool of lava ponded beyond natural levees south of vent A that lasted until the end of the eruption. So like a perched pond as well. Occasionally that pond spilled over its levees and fed lava down the westernmost of the 2 flows that had trapped the national park ranger. The lava is still coming down in that area. Small vents reopened for a few hours between the 25th and 28th. And they do note that the lava lake in Alai crater was overturning, and that brightness was also noted as activity at the time. It's something they could identify. Overturning occurs until the night of March 1st to 2nd, with the last ooze of lava on March 5th, as we talked about in the photograph there. When it was over, the lava lake, 70 meters, it's that 240 feet deep or so, was left, with 7 million cubic meters of lava partly filling Alai crater there. With large cones as high as 110 feet high over the vents A, C, and D. The chain of craters road had been cut by lava flows for the first time in history, right then, with a big area covered. And even though they had a hard time estimating the thickness of the flows, they estimate about 20 million cubic meters with maybe 25% error is what they estimate their accuracy to be there. So here's that series of cracks, a series of photographs, right there it is at the top left. The first crack opening up, it's getting wider, it's getting deeper. They back up, they see steam coming out of it. They see the sulfur gas, they start hearing a roaring and the clots of lava coming out. This is the same story that passed in Leilani in 2018. But here it was being witnessed for one of the first times by the USGS and photographed and documented in this paper. Yeah, so let's see here. We'll go past all this analysis. Here is one of my favorite images of this eruption here. So after that line of fissures reactivates between Alai and Aloe, across Chain of Craters Road, right in here, it leaves this line of cinder cones across there. So here's where the crack crossed the road right there. That's that same area. This road used to come like this and maybe like that. So the overlook at Alai was somewhere in here maybe. And so that's where they retreated from there to here and watch the cracks opening right here and this fissure opening right here. And eventually the next morning, after it reactivated, it was this line of spatter cones. So let's see what else we got here. I won't recap the signals. There's one photograph that didn't show you in full here. That's not it, this one. It's a little blown out there, but that's zoomed in. There's that mezzanine, beginning of that eruption. That fissure across the top is pouring lava down onto the mezzanine and then into the inner pit of Alai. And that's the one where we zoomed out, have this view here. yeah, so when it was all over, there was a big chunk of lava left there as a cross section of that crater in Hawaii. February 16 lava lake was a big thickness. There is the mezzanine bench right there. And that overtopped what by now was a solid August 63 lava lake, that other eruption, the third one in our sequence of 9 that had occurred as well. So that's how that fits together. And it's to be followed by all the stuff in May that begins the Maunaulu eruption there. And over the course of time, this is from the other paper, that changes over with draining and filling and filling and draining and draining and filling, more than we'll talk about today. And so that's the story of that February 69 eruption. And so here is to put it all back in sequence for you guys, all of them together, all 9 eruptions of the 1960s. And let me come back through and turn them on one by one. September 61, reach the furthest down all the way to the range of the Lower East Rift, that just across the boundary, but mostly was an intrusion, did not leak out a whole lot of lava. December 62, similarly, mostly an intrusion, did not leak out a lot of lava in this area right through here. August 63, that was the one only in a lie. There it is right there. Before October 63 comes, and now we start having our bigger flows. Here is Nepal crater. There is a first time it gets covered when we showed the images of lava trees formed in the bottom of the crater there, right? So this entire footprint, most of this footprint's going to get covered in the following eruptions here. So look at this blue as it stands now. Next we have March 65, right? That is also covers all of Nepal, covers a lot of this 63 eruption, and also for the first time goes into Makaopuhi, where the scientists can drive down to the end of the road and actually watch this happening, hike down into there, take lava samples, spray paint boulders, and watch the lava lake filling and rising and measuring all those rates. Right. And we have December 65 that occurs further up the rift on a slightly different strand. You might note that there's a northern line of fissures and strands and a southern line as well, right there. So we seem to shift to the northern one, which incidentally is the one that we currently have seen our intrusions on, is this northern line here in 2024. Then we have the summit eruption up at the summit up there, 67, 68. And then August 68 is this yellow. So that cracks and leaks out just a little bit of lava. It starts up here, but makes it all the way down. There's bits of it all the way through here. There's bits of it all the way, maybe not quite down that far, all the way to here. That's another intrusion with a little bit of leaking along this northern strand of line once again as well. October 68 is the one that follows that. And once again, that very similar area covers all of Nepal, and some of these areas now have 3 flows on top of them right in here, for example. And finally, the one we're ending with now, February 69, is the one that's going to change things and lead to the next, right? So here we are. There it is. That's a lie crater right there. And that fissure line, that flow that goes north, the flow that goes into Nepal in the red right here. Here are those ones, that event F that comes further on, was discovered later on by aircraft. So that's the full sequence there. And yeah, and really this one was the one that set the scene for what would come next, the eruption of Maunaulu right through here, right? And when we zoom out and see this big scar in the landscape, that was going to be the next 5 years of Maunaulu that followed. So that's a long-lasting eruption. This 9 years in between was a transition time. And that's what we're looking for parallels in history now. We're transitioning from having had Pu'u'ōʻō for 35 years to not having had it for the last 6 years now. And now the magma is trying to come back into this area, reestablish a path. And what you can see is it takes a lot of different injections along multiple strands here, puts a lot of the lava underground in this crack network. It can reach pretty far down sometimes, but even when it leaks out, it doesn't usually put out very big volumes of flows. It stays along the rift here until you eventually fill that rift enough that you start putting more lava out of the rift and your eruptions become larger volume and start running down a hill further and into the forest further, right? And then following that is when you have enough pressure to build up to one of these long-term eruptions, like one of these Maunaulus, like that. So that's our volcano awareness presentation to wrap up the 1960s. And what do you think, Dane? Has got some questions?
Good job, Phil. Yeah, good job. I just, this whole time, I think one of the themes that keeps coming back to me is how Puʻu'ōʻō and the 30 plus years of its activity, and then the dramatic 2018 kind of have people's perspective on what Kilauea normally does kind of twisted. And so to go through this decade really shows that those short eruptions, working its way into the rift zone, how long it can take, and the large variety, the variability that can happen between these different eruptions, from small little string ones that go a long distance but don't put down much lava, to something like Maunaulu at the end of it, big eruption, multiple years long, large volumes, big fountains, all that. So yeah, good job, Phil.
Different eras of activity, right? So like, I just, we're in a new era, and what era is it? We don't know. And so here we are, just looking at some previous eras to show you the kind of eras there can be on Kilauea, right? And this might be one of the more similar ones to what we get as it appears right now.
Will be interesting to see what the viewing is like on one of those eruptions nowadays. Just pick one, and it's going to be challenging, to say the least, to get any kind of views.
It'll be like before, right? Will it be like, well, it's in the middle of the forest, we can't get there. Can we fly over there? Maybe the next day. Maybe if
who's got a boat?
Not quite.
Yeah, right? Who's got a boat? Can we get there? Are you going to get seasick? It's all the same old questions. Yeah.
None of these gets to the ocean, right? But you probably can see from offshore, right? Right. You can't get to Chinook Craters Road, you can, sail offshore and try to look from there, I suppose.
Right. Puʻu'ōʻō spoiled people on the lava boats type of thing too.
Right. Right.
As you were saying about the old stories of hiking out for miles just to catch a faint glow. Right.
I remember seeing glow through fog, and I was like, I can see something orange. It really is a volcano. You're not just saying it, right?
Right. All right. Yeah. Great presentation. I didn't see any questions come through. And if I missed one, Lou, let me know. But yeah, good job, Phil. And it's awesome to get through this whole series. Oh, we did have a super chat come through. I didn't want to acknowledge that. We had a $10 donation from James Olson. Said just mahalos, just simple message there from James. Appreciate the support there. And then we also had a $25 donation come through on Donor Box from Nathan. So thank you guys. Appreciate the support. And yeah, both help. Definitely awesome. But yeah, I think that may be it for us. Get in another hour and a half normal time spot, and good job with that whole series. It's wrapping up, like, I don't know how long you've been working on it, at least a month.
I think it was August 22nd-ish is when we began it, because that was the anniversary, and that took us down this rabbit hole. And that was following the second intrusion, and so it's been a lot going on. And so now I can refer to these and refer to this era maybe a little bit more easily. Look at the imagery and some of the patterns from the past, and a little bit more focused now. And I myself did not know this detail of the history, having hiked out the trip to Nepal so many times to go look for that glow at Puʻu'ōʻō, for example, right? So I do see some of the comments Yvonne's got here, that all kinds of features on there, a piece of the old road. It's really cool to see on that trail. So a lot of cool stuff, and now even more things to look for, right? Right in here might be pretty tough to figure out which flow is which, but it might not matter. It might still be really exciting. So interesting times.
We did have a $10 super chat come through as well from HG. It says, awesome presentation, Phil and Dane. Mahalo. Thank you for the support. Keep the digital lights on, as I say.
All right, well, we've been gone long enough. We've gone long every week, so we'll just cut it off here. So thank everybody, especially
We'll be
our
back.
ASL interpreters. Yeah, who
Yeah.
put up with our long discussions on flow after flow after flow after flow, right?
Yeah.
So yeah, I'm glad to have them on
Thank
board as
Lou
well.
on the back end as well, and Yvonne for the photos that she's been taking for us down there in the park. Awesome.
Yeah.
We will be back. Our standard time is 5 p.m. on Thursdays, every Thursday. Unless something happens, we get an eruption or something, you know, crazier things have happened, then we'll go live and talk about that. But barring that, next Thursday, same time, same place.
Right. Mahalo, Dane. And yeah, from our nonprofit HVERI team, I'm Philip Ong, Dane DuPont, Daniel and Carrie, and Lou in the back end. Aloha, everyone.